5.3, which is the polynomials unit, modeling data with a line of best fit. So Nathan wonders whether he can predict the size of a person's handspan based on the person's height. His math class investigated this relationship and recorded the measurements from 15 students in a table below. So what we want to remember is that our first column is usually going to be our x's. So we're going to put all our heights into our x's here, and all our handspans into our y values. Okay, so those are our y values. So our dependent is always our y. And we can describe this as the data is the handspan. So the y coordinate is the handspan. What is a reasonable domain and range for this information? Let's talk about the domain first. So the domain is the x coordinates that are allowed. So we're going to put x such that, so we're saying what's a realistic minimum that's allowed and what's a realistic maximum allowed, where x is greater than or less than a certain value. So we're going to always have our inequalities opening to the right. So our smallest height, if you guys look, it looks like it's 165. So that's going to go to your left side. So 165 is going to go to the left side of that x, and your highest amount seems to be a height of 180, 2.5. And then we would say XER, because there are values in between there. Any kind of height in between those would be acceptable. Okay, so our smallest height up to our largest height for when it comes to domain. For range, same thing, you're just looking at the y coordinates now. So you're going to say y such that. Our smallest handspan looks like it's 16. So we're going from our smallest handspan up to our largest handspan. Looks like the largest is 25. And then we would write YER. Okay, so that's answering our first question, what's the domain and range. Now we're going to find the line of best fit, and to do that, we're going to follow the steps from above. If you guys go to kind of your first few pages, it gives you a bunch of kind of steps here. So we're actually starting from step number 5 here. So we're starting from step number 5 and continuing on. Okay, we're not going to turn on the scatter plot. We're not going to do that scatter plot value. So we're going to kind of ignore number 7, and then we're going to continue up to 8 and then kind of answer the question. And then we're going to graph it, etc. Okay, and that will help us answer questions. So the most common one is step 1. We want to start by clearing our list. So if you look at number 5, the steps are you have to press second plus sign number 4 in your calculator and then press enter. So that's what we're going to do first. So in your calculators, we're going to start by pressing second plus sign, which takes you to this menu here, second plus sign, number 4, and you're going to press enter. So second plus sign number 4, enter. What it should say is, it should say clear your list, and then it should say done. Once you've done that, you're going to go to stat. So you're going to press this stat button right here. So there's stat, and it takes you over here. And then you're going to press 1, or you're just going to say enter. So you have choices here. So press 1, and it should take you to this menu here, where you're going to always enter your x's into L1 and your y coordinates into L2. Okay, so again, to get to that menu, I press stat, number 1, and it takes you to the chart that you need to. So what we're going to be doing is we're going to be entering all these values into, so we're going to go back to our original kind of data. This is our data that we had. We're going to enter all the x coordinates, which are the heights, into L1, and all the handspans in order into your L2s. Okay, so that's what we're going to do right now. So you can follow along and use that to do it. So our numbers are 165. And then you press enter and it goes to the next number. Our next height is 172.5 and so on. Okay, so I'm going to enter all my heights first. So take the time to make sure that you don't make any errors when you enter this data, because if one value is off, then it's going to affect all your other ones or all your other calculations. So I'm just entering all my x coordinates in order that I see them in. So there's 2 columns that you have to put in for height. Okay, so once you enter all those data values, you're going to go to your L2 and enter the handspan, which is your y coordinate. Oops. Make sure your values match up. Okay, so once you've gotten to the end and you've entered all your data values, now we're going to actually find out the equation. So this is called a line of best fit. So for question B, it says, what's the line of best fit? A line of best fit always refers to a linear equation. So if I go to my notes, when it says line of best fit, it's a linear equation. So they want all the numbers that I get rounded to the nearest thousandth, which means, this means 3 decimal places. So in our equation, our next step in our calculator is we're going to have to press stat. You're going to go to the right until you get calc, and you're going to look for linear regression. So linear regression is number 4, guys, number 4. So for this part of the unit, we're going to use only 4, 5, and 6. Don't go over here. This is not what we do not want to use number 8. So use number 4 by pressing 4. And then for your calculators, keep pressing enter until it gives you this equation right here. So keep pressing enter until it gives you this. So your goal is to see, do you get these numbers? If your numbers are off, that means that you should go back to your chart and double check if there's any errors that you made in this. So we want to have 3 decimal places for each of these numbers. So again, to get this equation, I press stat, calc, number 4, and you get this. So now you're going to write it down. Y equals ax plus b. You're going to fill in your ax plus b values. Your a, you're going to replace with the numbers we just got. So once I calculated it, once I press enter until it calculates it, you get these values here. We want to have 3 decimal places for our thousandth. Okay, so when I write down my equation, I'm replacing a and b with these numbers. So your final step should be to write y equals a needs to be replaced with the value of a, which is 0.226 when I round it to 3 decimal places. X should always be there. Y and x have to be in there for it to be an equation or a line of best fit. And then subtract, because it's a negative sign, 18.305. So this is the answer I'm looking for the line of best fit. Okay, so once you learn those steps, you'll see that it pretty much repeats itself. So what we want to do for the next one is we want to make sure that we're able to do a scatter plot. So graph a scatter plot is where you put the year, which is the y coordinates, or sorry, the x coordinates would always go at the bottom. So that's your year, so that's the x coordinates. And your y coordinates in this case would be the bottom kind of row, which would be the distance. And then we would start by putting this little zigzag thing to show that we're skipping years. So the zigzag goes along the years because we're going to start from 96. So we're going to make the first kind of notch at 96, and then we're going to go up by 2. So this will be 98. Let's see if it works. 0, 0, 2, 0, 4, 06, 08, and then 2010. So that's 1996, 1998, 2000, 2002, 2004, 2006, 2008, 2010. And then for distance, again, we're going to create that little zigzag to show that we're going to skip values, and maybe we're going to start from 75. Then I'm going to go up to 80, 85, and then 90, and then up to 95. Okay, so just to be able to fit all the distances. And then what you're going to do for a scatter plot is plot all these values. So at year 96, we know that we had about 78.04. At 98, we had 79. At the year 2000 or the year 1999, we had 81 approximately. At 2002, we had 82. 2003, we had 83.72. 2004, we had 84. 2007, approximately 86. 2008, we had 87. And then 2009, we had about 90.6. So I'm just kind of estimating. So the reason we do this is a nice way of estimating what graph should we use. And if you look at this, the trend looks like the line of best fit would be a linear equation. So there would be a straight line, and it would go through as many data points as possible. So we've graphed the scatter plot, and now we need to determine the equation of the line of best fit to the nearest hundredth. Hundredth means 2 decimal places, 2 numbers after the decimal. Okay, so we're going to do the same thing we did before. We're going to put the year and the distance into our graphing calculator. Step 1 with your graphing calculator, you need to clear your list. You have to do second plus sign number 4. Second plus sign number 4. Press enter. It should say done. Next, you're going to go to Stat and number 1, Stat 1. This is where you enter your values. So we're going to enter 1996, 1998, all the years into your L1. So those are your X coordinates. 1999, 2002, 2003, 2004, 2007, 2008, and 2009. Next, you're going to put in your distances into your L2s, exactly how you see them. So make sure that you don't miss anything. So I had to check. Okay, so make sure that you don't miss any values. So even take a second to confirm that you didn't make any errors as you were entering your data. Okay, mine looks okay. Once you have entered your data, you're going to press Stat, Calc, and again it tells us that it's the equation of a line of best fit that we're trying to determine. So we go to the right where it says Calc, and number 4 is linear regression, which is another name for a line of best fit. So press number 4. And keep pressing enter until it calculates it for you. So you should be getting y equals ax plus b, where a is equal to 0.86 because you're going to round to 2 decimal places, and b is equal to negative 1635.73. So we're writing these numbers down, and then we're going to record them, but we need to write them as an equation. So make sure that you do finally write it as an equation. So I'll show you what that looks like. So you're going to write y equals, a needs to be replaced with 0.86, x stays as it is, and then minus, because it's a negative number, 1635.73. So that's rounded to the nearest hundredth. 2 decimal places as your final answer. Okay, now to answer any question further on, what we need to do is we need to go to, when we have our description, when we go to our descriptions on what to do, this is where you want to graph the equation. So we're at number 9 right now. And then we're either going to solve for either number 10 or 11, depending on the question. So we're kind of at number 9, 10, 11 steps for the next few questions. So if you struggle with remembering the steps, go back to this page and it'll tell you what buttons to press. So we're going to go to y equals, we're going to do vars. This is going to copy and paste our equation into our graphing part so that we can graph it correctly with a lot of accuracy. Okay, so our next step is, in order to answer any questions based off of this, we have to start by pressing y equals. We got to clear whatever's there, and we need to press then vars next. Vars, number 5 for statistics. You go to the right until you get to EQ, which is equation, and press number 1. What that's going to do is the equation that you just got, it's going to drag and paste it with all this accuracy. So do you see how we only had like 1635.73? It's going to give you all those decimal values that follow, and this is going to be really precise. So it's very important to be precise in these questions. Okay, and then you have to pick the right window. This is where that domain and range will help you, right? So our smallest year, you're going to go to window next, and our smallest year went from 1996. So let's use that for now. And our biggest year was 2009. So we're going to use that for our x values. The smallest to biggest year for x's. And for y, we're going to go from the smallest distance, which was about 78. We don't have to have the decimal places, up to approximately 91. So I'm rounding from 90.6 to 91. So those were our smallest to biggest values for our distance. And then you're going to graph it, and you're going to get this straight line, which is a linear equation. So the question is, our first question, if you guys look at it, it's asking, interpolate a possible world record for the year 2006 to the nearest hundredth of a kilometer. So we want to figure out what the distance is when the year was 2006. So the steps are, if you're ever trying to figure this out, you have to say what this is. Whenever we talk about years, that's the x coordinate. So they're giving us x equals 2006. Our question is, what is y? So to do that, you're going to press trace in your calculator, x equals 2006, and then you're just going to press enter, and that will answer the question for you, as long as the window's correctly set. So in our graphing calculator, you're going to press trace always. If they give you the x, you're going to enter 2006, which is the year, and you're going to press enter. And this is going to give you the y coordinate, which we can see right here. The y answer is, we have to the nearest hundredth, 86.38 kilometers if you round to 2 decimal places. Okay, so I'm writing this answer right here, but I'm rounding to 2 decimal places. Okay, so I recorded that. There's my answer. I put trace, x equals 2008, enter, and I got this answer. Now they're giving us another year. Now they want us to find the world record distance in year 2000, so very similar steps. Now we know that x equals 2000. So again, we're trying to find the y coordinate, the distance, the world record distance, the year 2000. So very similar steps, well, exactly same steps, except for instead of x equals 2006, you're going to enter x equaling 2000. You're going to press enter, and that will give you your y answer. So in your graphing calculators, you should be putting now trace, year 2000, enter. And this is the world record distance. Again, they want you to round to the nearest hundredth of a kilometer, so 2 decimal places, so 81.23 kilometers is your answer. And then I'll just highlight that. So that's my answer right here, round to 2 decimal places. Okay, so I wrote that down. So there's my steps and there's my answer. Now this is a different question because now they're giving you the world record distance. So they're giving you the distance. Now this is a y coordinate. So y is equal to 94.56 kilometers, and what they're asking for is x. So this is a different step. So we have to make sure we know what they're giving us. Are they giving us an x or are they giving us a y? If they give you a y, what you're going to do is you're going to go to y equals, and you're going to put under y2 that world record distance, 94.56. Now you need to confirm that your window is able to see that. If you guys go to the window, you'll see that our y coordinate only went up to 91. So we would not see that answer if we didn't extend this. So we have to go to higher than 94.56, so we can round up to 100, for example. So I'm going up higher than I originally had, because otherwise I wouldn't see that 94.56. So step 1, y2, put 94.56, double check that your window can see that number in your y's, and then graph it. So what you should see is these two graphs are trying to meet. The answer is where they meet. So we need to see more of this, which is called your x max. So we don't see enough of our x max, which we know it's going to be farther or higher than year 2009. So let's go higher than 2009. Let's go up to the year 2020. So the year 2020, we're going to graph it just to see what if there's an intersection. So if you don't see an intersection, your window is not big enough. So there it is. We need to find this intersection by doing second trace number 5. And you're going to press enter 3 times. Enter, enter, enter. So this will tell you the year. Your x coordinate is about year 2015.5. So we can say approximately 2015. Or if you round up, it would be like 2016. So I would go for the 2016 because we're kind of rounding up because it's 0.5. So I would say approximately the year 2016. So to do that, remember I press second trace number 5, and I just pressed enter 3 times. Enter, enter, enter. And it gives you the answer, which is the intersection, and it's the x coordinate that we needed. So x equals approximately year 2016. Okay, so we got that written down. We're good. So those are kind of the main ideas for this lesson. If they give you a x, you have to be able to find y, and if they give you a y, you have to be able to find x. So let's do our last question. So again, we need to enter this data to be able to answer these questions. So let's go to our calculator. Step 1 with our calculators, we always clear our list. We do second plus sign number 4. Second plus sign number 4, enter. Clear our list. Second plus sign number 4, clear list. Now you go to stat, and as you can see when you press 1, stat 1, you have a clear list because otherwise the data from the previous stuff stays. We need to enter the number of t-shirts into your L1. So that's the number of shirts. And then your L2 will be the cost of the t-shirt, which depends on how many t-shirts you buy. So your y coordinates go into L2. Okay, so once you've entered all your values, double check that everything's correct. They want the equation for the linear regression, which is another name for a line of best fit for A. So you're going to press stat, calc, go to the right till you get to calc, always number 4 when it's a line of best fit or if it's linear regression. Number 4, keep pressing enter until you get the equation. So now we're going to rewrite y equals ax plus b. A needs to be replaced with negative 0.0065. It doesn't tell you what to round to, so you can keep all those decimal places. And then we have to add 6.5. So we have to replace these values. This value replaces your a, this value replaces your b, the plus sign stays. Okay, so I wrote that down right there. There's my equation. I answered question A. Next, we want the slope. The slope is always the value that comes in front of your x, which in this case is your a. Your a is negative 0.0065. That's your slope. What it represents is how the price is decreasing depending on how many shirts you buy. So for every shirt that you buy, your price decreases by this. By not even like a cent. So every shirt that you buy, your cost will decrease by 0.0065. Next, your y-intercept is the 6.5. That's your y-intercept. It's always the constant when we have linear equations or if there's no brackets. Whenever it's a polynomial, it's always the constant, which is in this case your b value is your y-intercept. And that represents the initial cost or initial price that they're going to charge you for making an order. So they're going to charge you $6.50 just to make an order with this company. Okay, so $6.50 just to make an order. Next, we're going to answer our question. They're telling us that we want the price of the shirt to be less than $1.50. So they're giving you the Y. Remember, this is your Y. Cost of shirt is your Y coordinate. So what we need to do is use our calculators to graph this and figure out what is our X coordinate. How many shirts will give us $1.50 or less. So step 1, go to Y equals, clear whatever you have there. And you're going to always press vars under Y1, number 5 for statistics. You're going to go to the right and press number 1. So it copies and pastes the equation for you. And since we're given the Y value of 1.50, that's where you have to put it under Y2. So whenever they give you a Y coordinate, put it under Y2. Now you need to make sure your window can see all this stuff. So we have to go to our window and we have to set our number of t-shirts going from maybe 500 to more than 740 because we're going to have to reach a cost that's less than $1.69. So let's go higher than our number of t-shirts. So instead of going to 740, let's go up to 1,000 t-shirts for now. Let's see if that's enough. And for Y, we need to go from at least 150. So let's go from $1 to 520. Do you guys see how our biggest value is 520? But remember, for our question, we need to be able to see $1.50. So I'm going from, oops, our scale should be 1. Yeah, so our minimum should be from $1 to $5.20 for cost because 150 will be between these numbers. So this works. So this is the number of t-shirts from 500 to 1,000. I rounded up. And for here, I rounded down to be able to see $1.50. Now graph it. The question is, if we graph this properly, we should see an intersection, which is right there. Anytime they give you a Y, you're looking for intersection by pressing second trace, number 5. And you're just going to press enter 3 times. Enter, enter, enter. Okay, and there's your intersection. So we want to round up because if we round down, we're not going to reach this $1.50. We have to round up no matter what it actually says. So our steps, so when we go to our actual sheet, our steps were, we had to enter our equation. This is how you show your steps. Y1, we had the equation. Y2, we had $1.50. And then we had to press second trace number 5 to find the intersection, which was this. So we had Y1 as the equation, Y2 as the $1.50. This is loading, taking time. Second trace number 5. So remember, second trace number 5 is how we find the intersection. And then you press enter 3 times until you get that number. But in order for us to reach $1.50, we have to round up. We need to order more t-shirts. So we're going to have to order 770 t-shirts for us to actually be $1.50 or less. So we're going to get charged less the more t-shirts we buy. So we actually have to round up for our final step. Okay, so the biggest thing is, instead of writing 769, because logically we would want to do that, we want to round up because we need to reach a cost of $1.50 or less. There you go, 770 t-shirts. So that's our final answer. So that's our lesson 5.3. So remember, at any time you could have paused this video. You could pause this video to make sure that you don't have any questions or to rewatch certain parts. I hope you guys have a nice day.